Hello. So go ahead and pause this video if you need to so that you can copy down our notes page. And oops, I don't think I forgot. I forgot to finish our learning target. So we'll write the definition down later in the video, but we do know the equation and pattern of logarithms, which we also could just call logs. So based on what we did the other day, we have log base b, so that b is in this subscript, of x equals y. And the pattern that we know that helps us solve is because this setup is equivalent to the exponential form, which ends up using that b again as your base. And then the output, that y value, becomes the exponent. And that number, or what your log is of, is now the output, what it is equal to. And now I also want to talk about the inverse a little bit here. So we know that finding the inverse equation, the easiest and quickest step we can do is to just flip the x and the y values. So I'm going to do that for both of these. So since what I've got written in is red are equivalent to each other, I've got log base b of y equals x is the inverse of both of these. But we could also write it in our exponential form, which means b to the x equals y is another way to represent the inverse of both of those red equations. I'm just going to write myself another reminder here that these two equations that I've written in blue are equivalent to each other. Alright, our next problem, we are asked to finish this table, which represents g of x equals log base 5 of x. And we're going to see if we can use our graphing calculator with that log button, which is over on the left side. So if I take that very first point, log base 5 of 1/5 equals -1. So I've just plugged in that input, wrote that -1 as my output, and I'm going to try and plug it in my calculator. So it automatically put those parentheses there for me. So I'm just going to play around and see if maybe the first parenthesis is going to be that base, the second parenthesis is that value, but I did not end up getting -1. So let's try another setup. Maybe I don't need to write the base. Maybe it's already in there. Whoops, so syntax means I've got something that's not closed, so I got to get rid of my other parenthesis. And again, I did not get the -1 that my table wants me to. What about log just of 5? Nope. But maybe that was just a one-off, so it's always better to check multiple. So again, I'm going to press that log button and I automatically get those parentheses. So I'm going to try it with the base and then another parenthesis for the value. I did not get 1. So no, we cannot use our calculator. with that, or we can't use the log button on our calculator to solve. Not yet, at least. So take a second to read that little piece of history, and it does end up giving us the definition of logarithm. So the logarithm, it represents the function that is the inverse of an exponential function. So in general, describing inverses just means our x and our y values are flipped. And then we also know when I'm dealing with logs and exponents, if I need to write something in that y equals form, then I'm going to use that equivalent equation. So for log, it will help me go to an exponential function and vice versa. So for our first one, y equals log base 9 of x. My first step, I'm going to apply the inverse idea, flipping our x's and our y's. And then I'm going to apply the second idea, which is swapping forms into that other equivalent form. So my base of 9 is now my base of 9, but in an exponential. That output of x becomes the exponent, and that value of y becomes my output. And then we're done. And then since we don't have the inverse notation, I'm just writing myself a note that this exponential function is the inverse of my original log function. Alright, so now we're going to try in the other order. My first step is still to use my inverse idea of flipping x's and y's, and then going into the log form. So log will always be there, and then we've got the base of 10, that output of x becomes the value, and that exponent of y becomes the output. Now for part C, don't get freaked out by x plus 1. Right? That stuff in the parentheses is still just the value, or it's that number symbol that we used previously. So all of the same rules apply. First, going to flip my x's and my y's. Then I'm going to write it in the equivalent form. So I'm going to take that base of 6 to start my exponential function. That output of x becomes the exponent, and my value of the log becomes the output, so y plus 1. So we've got one more step if we want to isolate that y and fully get it into that y equals form, which is just to subtract 1 from both sides. So now y equals 6 to the x minus 1 is my final inverse. And now that same idea is going to apply for part D. Right? That exponent of 2 of x is still just the exponent. All of the same rules apply. So just flipped my x and my y. The 2 stayed where it was. Now I have a log base 5 of that output x equaling the exponent of 2y. And then again, we've just got one more step to fully isolate y by dividing by 2 on both sides.